So now we're going to use Excel to analyse some of the temperature readings that I've taken earlier. I'd like to, I have in my notebook a log of temperature versus the voltage readings across the thermistor, and I'd like to be able to plot some graphs and see what's happening there. So Excel is great for doing that kind of work. So here I've gone into Excel and I'm opening a new spreadsheet, and I'm going to key in the data in 2 columns, voltage and temperature. Now I've entered all the data, my voltage and temperature readings, and this is where Excel gets really useful. I'd like to plot a graph of temperature versus voltage. So to do that, I'm going to select the top cell here, and then I'm going to highlight the 2 columns of data right down to the last sample. Okay, I'll release the button, and I'm going to go up here and pick the tab called Insert. I'm going to go to Graphs, and I'm going to go with this type of graph. Now you have a whole selection there that you can play with and try out. Click that, and there's our graph. Okay, now the scales maybe aren't perfect, but you can still see we have temperature along the side here going from -10 degrees up to +35, and there's all our data, and here's the voltage along this axis. Now if I was going to present that data, I would do a little bit more work, and we'll look at that in some other videos of how to make the scales and axes to label them better. But for now, what I'm interested in is the fact that this looks like a straight line relationship between temperature and voltage, and that's what I'd hoped for. So I'd like to find what the equation of that line is. Now I'm sure your maths teacher can show you ways to do that, but we can actually get Excel to do that for us. So I'm going to come up here and look at different forms of chart, and I'm going to select this one. If I click on that, Excel works out the best fit line equation and draws it in there and gives us the equation for it. Okay, so if I use this equation here, it's y equals, in my case, -16.5 x plus 51.7. Now that will vary depending on your thermistor and the exact circuit you've used. But what it means is y is temperature and x is the voltage reading. So I can use that formula to generate temperatures from voltage. Next step is to take that information back to the Arduino program and pop it into a few lines of code. So I've made a note of the formula, and now I'm going to move back to the Arduino and add that equation into my temperature program. So this is the simple temperature program that we did earlier. Okay, it's just reading in the voltage from the thermistor. It's not actually giving us temperature. So I'm going to key a few lines, extra lines into this to add in a conversion from voltage to temperature. Here's the adapted temperature program. So here was where we read in the analog voltage, and we the analog reading, and then we converted it to voltage. Now I've added a new line here with a new variable called temperature, which incorporates the equation for the line. So it's taking the voltage, multiplying it by something, and adding this constant. That's the data that we worked out using Excel. And then here I'm sending all this information back from the CanSat. So we're sending serially the voltage and the temperature. So if I connect up my Arduino, and I just connect it into the port here. I'll upload the program, make sure I'm on the right port. Yeah. So I'm going to upload this code to the Arduino, and then we'll have a look and see our temperature readings coming in. I'll open the serial window, and here you can see the voltage reading that we would have got before, but now it has also added in a conversion to degrees Celsius. So now the Arduino is giving us temperature readings in degrees Celsius, and we can be confident that those readings are reasonably accurate.